So yesterday we started talking about quadratics, and you were solving them to find like your roots or your zeros or your solutions. And so today we're going to figure out what exactly that means and a bunch of the other characteristics for quadratics. So today is just like getting you used to them, introducing you to them, what they are, what they look like, what they do, all that stuff. So the first thing that you've got here is your standard form, which I think we've talked about this a lot already, right? That x squared plus x plus whatever. So that was like our descending order when we were factoring stuff. Do I remember talking about that briefly yesterday? So your standard form for a quadratic, that's the form that we want it in, is ax squared plus bx plus c. So the a, b, and c are any number as long as a isn't 0. If you don't have an x squared, it's not going to be considered a quadratic function, so you just got to make sure that you have something in front of x squared going on. So do y'all remember when we talked about degrees of polynomials a while back? Gosh, that was probably like over a month ago. Do y'all remember talking about that at all? Degrees of polynomials. That's like your exponent, whatever your highest exponent was. Do y'all remember doing that? So anytime you've got a quadratic, the degree is always going to be 2, or like second degree, because you got to have that x squared. If you don't have that x squared, it's not going to be quadratic. Okay? Alright, so for the first section right here, we're just going to say what a, b, and c are. So a is the number in front of x squared, b is going to be the number in front of x, and c is the constant that's all by itself. So if we're looking at number 1 right here, what do y'all think a is? So a is just the number in front of x squared. So we don't want x squared, we just want 9. Is that okay? So what about b? That's the one that's just in front of x. -7. So whatever sign is with it, you got to take that. So we can't just say 7, it's got to be -7. And what's c? What's our constant? E. Good. Questions on any of that? Pretty straightforward, right? Okay. So for number 2, Tori, what's our a value that time? Your a value. Remember, a is in front of x squared. So y'all, is this one in standard form? No, so we can't just pick the first, second, third number, right? You gotta look where stuff is. Jacob, what's our b value? 3. That's the one that's just in front of x. And Catherine, what's our c value? Your c value is your constant, so it's all by itself. -2, you gotta take the sign with it, whatever sign it's got. Is that okay, y'all? So that one's not in order, but it's still like the same thing. So your a is still in front of x squared, your b is still in front of x, and your c is still the constant all by itself, even though it's not in order. Is that okay? Alright, so looking at number 3, is that one in standard form? Would it be helpful for us to rewrite it in standard form? Does anybody need that? Alright, Riley, what's your a value? Riley? What you got? -1. Abigail, what's the b value? 2. And Ethan, what's the c value? 6. Is that okay? Questions? So we're alright with that? Yeah. Okay. So that's the easy part. So now we're going to start talking about all the characteristics. So there's going to be a bunch of stuff here, and I'm going to write a bunch of extra stuff here. So anything that I write, what should you do? You should write it as well, okay? So this shape of a quadratic, we have a fancy word for that. It's called a parabola. Depending on where you're from, you may call it a parabola if you're real country. But a parabola is how you say that, like, properly. And I can't spell P-A-R-A-B-O-L-A. So that's just like a U shape, so it's going to look something like this. And we'll call that a U shape. So it could open up like a U, or it could also open down, and then it's going to look more like a frown or like an N. So either way there, it's still a parabola, it's still a quadratic. For its symmetry, we have y-axis symmetry. So your y-axis is the one that goes up and down, right? So that just means that you could take your parabola and fold it on some axis that's straight up and down, and it's going to be the same on either side. So that sounds a little weird right now, but once we start graphing them later, it's going to make a little bit more sense in context. So it's got y-axis symmetry. And so we have what's called an axis of symmetry, which I think I just said that a second ago. And so that's that imaginary line that goes down the middle of your parabola that we could fold it on, and it's going to be the same on either side. So what I mean by that is, like, you've got your U shape, yeah? You've got your parabola, and there's this imaginary line that goes down the middle, and we could fold it, and it's going to be the same on either side. Does that make sense? Do we know what symmetry means? Like a butterfly, it's the same on each side, right? So that's what this is talking about. So there's a little bitty formula to help you get your axis of symmetry, and that is x equals negative b over 2a. So y'all, that's why we have to know what that a value is, what that b value is. That's why you've got to be able to do this up here, so you can pull those numbers to plug into this formula here. We're going to do all this later, so right now it's just a bunch of information coming at you. And so this is going to give you the x value of your vertex, or the axis of symmetry. So your vertex, do we know what that word means at all? Have we heard that word before? Have you heard that word before in, like, maybe like elementary school? We talked about like the vertex of a shape.
Yeah.
And what was it? It was kind of like a, yeah, like a point or like a corner or something like that. Have y'all heard that before? Vertices, yeah, you may have heard of like that. So that's just like more than one. So your vertex for a parabola is your turning point. So it's like the bottom of the U or the top of your N. So that's either going to be a minimum or a maximum. Depending on if it opens up or down. And we call that your vertex. So if your parabola looks like this, your vertex is down here. Is that going to be like a minimum value or a maximum value? What do you think? Minimum, right? Because it's at the bottom. Now, what if your parabola opened the other way? It was upside down. It would be a max, because it's going to be the highest you would ever go. Does that make sense? Are we okay with that? So this one right here, your vertex, is your turning point down here. Is that going to be a minimum point or a maximum point? No, because it's the lowest it's ever going to go, right? So now flip this, pretend it's upside down. Is it going to be a minimum still or a maximum? Maximum, because it could be up at the top as high as it would ever go. Yes, kind of. Is that okay? Yeah, if it's flipped, it's going to be different. We all right? Yeah? No, maybe? Okay. So that's that. So your axis of symmetry, this formula right here, that's going to give you the x value of your vertex. So like this line that I just drew is cutting down right the middle of your vertex. So then to get your y value, you're going to plug back into the function that it gave you. That's a lot right now, and we're going to do that later. So don't stress about it right now. We'll do that at the bottom of the page. What else do we need to talk about? Roots. Did y'all hear that word yesterday at all? You did? Yeah. What were we finding yesterday? Do you remember? What did we call them? It's what it equals. We called them like solutions. Do you remember doing that? Your solutions, your roots, your zeros, your x-intercepts. So your roots are where you cross the x-axis. So we also call those, I'm going to put AKA, zeros, solutions, or x-intercepts. So zeros, roots, solutions, and x-intercepts are all the same thing, and that's just where you cross the x-axis. I want to backpedal for just a second. We talked about the minimums and maximums, can we draw what those look like as well, just so you have a reference? So we said earlier that the minimum is going to be like your lowest point. So your vertex would be down here, and that would be your minimum. And then we said for a maximum, it's going to be like flipped. So your vertex is at the highest point, and that's a maximum. Yep, the whole graph is flipped the other way. Huh? There is one point that is going to be a maximum on that. It's going to have a maximum at the vertex. This one's going to have a minimum at the vertex, because that's the lowest it ever goes. No. There is one point that is a minimum. That's the lowest point you could go. There is one point that is a maximum. That is the highest point you could ever go. Okay. Are we all right? Any other questions right now? I know this is like a ton of information coming at you at once, but you'll be okay. You'll be all right. So let's write one more thing. So off to the side, this is what they're going to ask you for the most. They're going to ask you to find zeros. They're going to ask you to find roots. They're going to ask you to find your x-intercepts. They're going to ask you to find solutions. All of those things are the same. And we found those yesterday. How did you find those? What were you doing? You set your equation to 0. Then what do? Factor, and then what? So you're going to factor, set your factors to 0, then what?
Solve.
Factor and solve. That's what I'm looking for right there. So anytime it says, like, find your roots, find your zeros, find your solutions, find your x-intercepts, anything like that, you need to factor and solve. That needs to be, like, hardwired into you. Anytime you see those words, factor and solve. That's what you need to do. Is that okay? Okay. That's it. That's all we're going to do there. We all right?
Yes.
Completely overwhelmed? No? Okay. Okay, good. All right, so we are going to graph some. So we did a little bit of this with your bell ringer, just like warming it up. So we need to make a table. So we're going to plug in some x values, and then we'll get some y values to go with that, and then we'll plot our points. So we've got x squared as our function, and we want to get a graph. So if we have a graph, we probably want to have some negative numbers and some positive numbers, so we know what's going on everywhere, right? So let's do like -2, -1, 0, 1, and 2. Those are my favorite numbers to plug in just because they're small. We get some negatives, we get some positives, we got zeros, so we got all the things we need there. So we're going to plug this in. So what is -2 squared? All right, so -2 squared is going to give us 4. Then we're going to do -1 squared. And what is -1 squared? 1. And then we'll do 0 squared. And what is 0 squared?
0.
Then we've got +1 squared, which is 1. And we've got +2 squared, which is what? 4. Anything's a 0 power? Alright, so let's plot these points. We've got the point -2, 4, so we'll get that going. -2, 4, losing the lines. And -1, 1, 0, 0, 1, 1, and 2, 4. And we'll connect our dots there. And we've got our little graph going on. So we've got that U shape, which is what we should be doing. So it's a U, not a V. So when you're connecting those dots, try to curve it out a little bit so that it's not like pointy but more rounded. And do you remember the name for that? What do we call that shape? Parabola or a parabola. Yeah. Is that okay? All right, so there's your graph, and it opens up. So is this one going to have a minimum value or a maximum value? It's going to have a minimum. We could find that. Can you tell where it's happening? At what point is that? 0, 0. So you might be asked for your minimum value. In this case, it would be 0, 0. Yeah. We talked about your axis of symmetry earlier. So again, that's like the imaginary line that you could fold it on, and it would be the same either way. So can you tell where you think that might be here? Probably right about the y-axis, right? Because it's just centered right there. So that would be like x equals 0. So again, that's that imaginary line that you could fold it on, and it's going to be the x value of your vertex. We're going to practice with that a lot more down here. We okay so far? Yeah? All right. So we talked about your minimum, your roots, your zeros, your x-intercepts. Do we have any? So where we cross the x-axis, does that ever happen here? Yeah. Where? Where does it cross the x-axis? 0, 0. So this point right here, 0, 0, that's your minimum, and it's your 0, your root, your solution. So I'm going to put root over there too. And then your axis of symmetry, I'll write that as well, was x equals 0. So that's a lot going on, but that's okay. Alright, so we're going to go do all that same stuff for the next note in here. So this time we have a little bit more going on, but nothing's really going to change. So when we're plugging in values for x's, we still want some negatives and some positives. Are y'all okay to still use -2, -1, 0, 1, 2? Alright, I like those numbers just because they're small. If you wanted to pick other stuff, you could, but you might run out of graph if you pick like real big numbers, so just be mindful of that. 2. Do you have calculators? Yes. You might need them for some of this because these numbers are going to get a little, there's a lot going on. So we're going to plug in -2 everywhere that there's an x. So we're going to do 2 times -2 squared minus 2 times -2 minus 4. Oh my goodness, that's a lot. You can just type that straight in your calculator. Is that okay? So I'm going to show you a trick that's going to make this a little bit easier for y'all if you're having to do a lot of these. So we're typing this in. Type it exactly as we have it written up there. So 2 parentheses -2 parentheses squared minus 2 parentheses -2 minus 4. Bailey, here. Hey. Sure. Catherine, do you guys see this table? Yeah. Where? My office? Our office, honestly. So you got that typed in? Yeah, and you hit enter, what do you get? 8, is that okay? Everybody all right with that? You've got to use parentheses, just like we did, because if you don't, it's gonna mess up. Because when you're doing that -2 squared, what is -2 squared? What is -2 squared? 4. If you don't put parentheses around that, your calculator is going to give you -4. Is that correct? No, so you've got to be smart. You've got to use parentheses exactly as we have it written on the paper is how you need to type it in your calculator. Okay, so you've got to use parentheses everywhere, everywhere, everywhere. All right, so we got 8 out. I'm going to show you a way to like make this a little bit easier. If you arrow up, it highlights what we typed in. So like go up twice so you can highlight what we typed in. If you hit enter, it's going to like copy paste that down. And then you can change all the -2's that we plugged in, but you can change it to a -1. That makes sense? So where I had a -2 there, I'm going to change that to a -1. And when we had the -2 squared, I'm going to change that to a -1. Is that okay? So once you type that in, what do we get out? 0. So then next we're plugging in a 0. So if you arrow up twice, we're just going to change all those -1's to a 0. And what do we get out? -4. Then we're going to plug in +1. Can y'all find the next 2 on your own? Yeah. Alright, Joe, what'd you get when you plugged in positive 1? When you plugged in positive 1, what'd you get? Don't do that. That's what we should be doing right now. -4. Ashley, what'd you get when you plugged in 2? 0? Okay. What do you think we would get if we plugged in positive 3? 3. We plugged in 3, so we one more. What do you think we would get? Why would we get 8? That's a pattern. It's repeating, right? Did y'all notice that on the first one that we did? I had 4, 1, 0, 1, 4. And is that starting to repeat over here too? Yeah. So we'd probably get 8 if we plugged in 3. So let's go graph that. So if we got -2, 8. So y'all, when we start to see that repeating pattern, that's because your axis of symmetry, right? So it's going to be on the same on one side as it is on the other. So that's why that happens. I'm trying to do this. 0, -4, 1, -4, 2, 0. I'm going to go ahead and plot that point 3, 8, even though we didn't put it in our table, just because it's going to help fill out that shape for us, that parabola. So if you're just looking at your dots, do y'all see how we kind of have like the two right beside each other right here? Are we going to connect them with a straight line across? Why not? That takes away your curve, right? And this has got to be what kind of shape? A U shape. It needs to be curvy. It needs to be a U shape. It's called what? Y'all are going to go into math too and be like, oh, Miss V talks about them parabolas. And they're going to say, oh, did she now? Just connect the dots. We okay? Questions right now? Okay. So where do you think that axis of symmetry is happening this time? It's not at 0. Is it on one number or is it in between two numbers? Looks like it's in between what? Where did we start repeating in our table? Between 0 and what? 1. So if you look between 0 and 1, about in here, we could draw that dotted line and it's going to be the same on either side. Yeah? Okay, so that's your axis of symmetry. We'll say that's at, I don't want to put a number there, but I'm going to label it AOS so we know that's our axis of symmetry. And it's happening, I'm going to put an arrow over here so we can see in our table where that's going to start happening. So in a couple of days when we start graphing these, you're going to have to put the axis of symmetry in the center of your table just so that you get a good graph. So we'll start doing that then. But yeah, I'm giving you too much information right now, so I'm just going to stop. We got our axis of symmetry there. Can you find roots or zeros or solutions or x-intercepts here? Do we have any? We don't have anywhere where we cross the x-axis? Somebody want to let her in? I mean, Caitlin's closest and just go look at her. It's okay. So we don't cross the x-axis anywhere, y'all? Here's the x-axis. Does it ever touch it? So right here and right here, those are roots. So I think there was a problem on your benchmark the other day that was talking about a negative root for a quadratic. Do y'all remember that? That would be your negative root because it's the one that's negative, okay? We'll do a whole lot more of this later, but that's where that's coming from. That's what that meant. What else? Oh, your minimum or maximum. Which one's this one going to have? A minimum point. Can you put your finger on it, kind of where that's going to happen? We don't know exactly where, right? Because we had to kind of guess a little bit, but it's going to be somewhere right there. Do you agree?
Yeah.
All right, cool. Let's label that as well. Is all this starting to make a little bit more sense? Like seeing it?
Yeah.
Okay. Questions right now? So the next section, we're going to find the vertex. So like before, on the first graph that we did, it was super easy to find. It was a good point. It was 0, 0. On this one, we know it's somewhere down here, but it's a little bit harder to find. So for cases like this, we're going to use that formula that we talked about earlier to help us find our vertex. So that negative b over 2a. Y'all need to memorize that, have it like ingrained on your brain. Make a tattoo on your brain or on your arm so you have it forever. Memorize it. Negative b over 2a. You got to know it. Okay, that's the x value of your vertex. I'm going to highlight that too. So your vertex, it's an ordered pair. So do we just need an x value? Is an ordered pair just the x value? No, it's an x and a y, right? So it's not enough just to have the x value. You've got to get that y value too. So we're going to find those. So for number 3 over here, we're going to use that formula, negative b over 2a. So I'm going to write that, because the more you write this stuff, the easier it's going to be for you to memorize it, because that's how you memorize things. You do it over and over. Negative b over 2a is the formula that we're using. So we're going to plug what we have into that. So we're going to have negative b. What is our b value? What is our b value? Negative 6 over 2 times a, and what is our a value? Why is it 1? There's nothing in front of that x squared. There's that imaginary one that we don't write. We know it's there, but they don't write it. Yeah? Is that okay? So up top, we have negative 6. What is that? Just positive 6. And on bottom, what is 2 times 1? And what is 6 divided by 2? 3. So the x value of your vertex is 3. Right? But is it enough just to have the x value? We've got to have the y as well. So, that's going to help you find an x. Is it a min or a max? Is it an axis of symmetry? So, we can already have our axis of symmetry, right? Because that's just the x value of your vertex. And draw arrows, we got that. So, I'm going to say AOS. And it's always going to be x equals. This was on your test as well, on your benchmark. And some of the answer choices were y equals, and some of them were x equals. So if there's 4 answer choices, it's asking for an axis of symmetry. 2 of the answers that have y's in them, are they going to be correct? No, get rid of them immediately. It's got to be x equals, okay? So your axis of symmetry is the x value of your vertex. X equals what? 3. So we got that part. We're all good there. So that means when we go to graph this little dotted line is going to be at positive 3. Yeah? The next thing, we got to find our vertex. So we know that the x value is 3, but we've got to find the y value. How could you find the y value that goes with that? Plug it in. So we're going to plug in to our original where we started. So everywhere there's an x, we're plugging in a 3. So you're going to have 3 squared minus 6 times 3 plus 4. We're plugging into the function that they gave us. And why are we plugging in 3? Where did that come from? That's the x value, your axis of symmetry. Yeah, that's what we got from negative b over 2a. So what is 3 squared? 9. What is negative 6 times 3? And plus 4. So what is 9 minus 18? What? Negative 9. plus 4. Negative 9 plus 4 gives you negative 5. So that's the y value at our vertex, negative 5. So the last thing that they wanted us to do was decide if it was a minimum value or a maximum value. And we haven't quite talked about how you can tell that yet. But if you look at your A value for this problem, what was it? The A value. What was the number for x squared? 1. So if that number is positive, that means your graph is going to open up just like it did here and here, because they were both positive A's. Do you agree? Okay. So if it opens up, you're going to have a what? Minimum. So this one, it had a positive A value. It's going to open up. So is it going to have a minimum value or a maximum value? Minimum. And we're going to write all this on the back. We're going to do some more with that, so it'll be there. So this is all of our answers there. Questions? Y'all ready to try the next one? Same thing again, okay? So we want to find our axis of symmetry and our vertex, decide if it's a minimum or maximum. So what's the little formula that we're going to use to help us find your vertex? Negative b over 2a. Every time you use it, I need you writing it right now because you got to memorize it. So we're going to have negative b. So negative, what is our b value? 4. And then on the bottom we have 2 times a. What is our a value this time? Negative 2. Now pause for just a second. Based on what we just said, since that a value is negative, is our graph going to open up or open down? Down. We're going to open down, right? Because this one was positive and we had a minimum. So this one's negative, so that's going to give us a maximum because it's going to open down. Yep. Yep. And you'll see that. You'll see it. We're going to do a ton of these, and it's just going to be patterns over and over and over. And like I said, there's a section on the back where we're going to summarize all this stuff so you have it in one place. So we'll get to that there. So we know this is going to be a max. I'm going to go ahead and jot that down here so we have it. All right. Let's evaluate this little negative b over 2a. So up top, you're still just going to have negative 4. And then on the bottom, we have 2 times negative 2. And what is that? Negative 4. What is negative 4 divided by negative 4? 1. So your axis of symmetry, what is it? Is it just 1? X equals 1, because it's that line, that whole dotted line, right? So you've got to have the x equals there. Then we need to find our vertex. So we have part of it. We know that the x value is at 1. How are we going to find the y value? Plug it back into the function that they gave you up top. So we're going to have negative 2 times 1 squared plus 4 times 1 plus 3. So what is 1 squared? And what's 1 times negative 2? Negative 2. And what is 4 times 1? It's 4 plus 3. What's negative 2 plus 4? And 2 plus 3 gives us 5. So your vertex is at 5. Questions? You okay? I know this is a lot. It's a whole lot, but you're going to get a whole lot of practice. Alright. So the next one we're going to graph. We're going to do this one in your calculator. Okay, we're going to use your calculator to help. So we want to graph y equals 1/3 x squared. So if we want to graph that, you're using your calculator to help. Where do you need to go? To a graph, right? So we're going to go to a brand new graph. And we need to type in 1/3 x squared. How do you get fractions here? How are we going to type that in? Just divide, right? So 1 divided by 3 x squared. And we hit enter. And it gives us that lovely little U-shaped curve. What do we call it? parabola. A parabola. Okay, we need to get this graph on this paper. So what would be helpful to have? Your points. How can you find your points? Your table, yeah. So how do you get the table come up again? Control T. Alright, so now right there we got like 0.333. Is that going to be good to plot? So can we just find good points and plot those? So I see one good point at 3, 3. I'm going to go ahead and plot that. Y'all see if you can find some more. Remember, we want some negatives and positives, so you might need to scroll backwards to find those. What's another good point we found? 0, 0. Any more? Negative 3, 3. And I think the rest go off the graph, right? Yeah? Okay, so we'll just have those 3. And that's okay. We know that this is going to be a little U-shape, so we can go ahead and sketch that in. Make sure it's got a nice little curve to it. And we've got our parabola. So we want to know what the roots are here. So again, your roots are where you cross the x-axis. Where's that happening? 0, 0. So you can write your roots as ordered pairs. That's what we're going to do today. Yesterday you wrote it just as like x equals whatever. So if it was like x equals 2, you could just say 2, comma 0 to make it an ordered pair, because y was 0 when you said it equal to 0. That's where that's coming from. What do you think the axis of symmetry is this time? What line could we fold it on? Right down the y-axis, right? It wasn't moved anywhere, so we know that that's going to be what? What does x equal there? 0. So x equals 0. And again, you can use your little formula to help you. Negative b over 2a, right? What is the b value here? If there's not one, what do you think it is? 0. So 0 over anything divided by anything is going to give you what? 0. So that's why we can just go ahead and make that step. X equals 0. Is that okay? Alright. Your vertex, where's it happening? Where's your turning point? 0, 0 still, right? And was it a maximum or a minimum? It's a minimum, okay. That was boring. Yeah. Is that okay? So what was your a value on this one? A equals 1/3. So it was positive, right? That a value was positive, so your graph opens which way? Up, right? Up, up. And then we had 1/3, and what did it do to your graph? So let's look at the first one we did, where it was just regular x squared. And then when we put a 1/3 in front, what happened to our picture? A lot wider, yeah? So I'm going to jot that down. We got wide here. So the next one that we're going to do over here, number 6, we got y equals 3x squared. So we're going to put that in the calculator as well, just to help us get some good points for that. So I'll do Control T, get rid of that table. And I'm just going to hit tab and delete out the 1/3. Sorry, this is like, can you see that a little bit better? Does that help? Maybe. So how are we going to get the graph from our calculator onto our paper? What do you need? Control T. We need some points from that table. So we'll hit Control T. You need some good points. What are some points that we could plot? 0, 0 is 1. What else? Negative 1, 3. Anything else? Positive 1, 3. What about 2's? What happens if you plug in 2 or negative 2? What do you get out? 12. So that's going to go past our graph, but I'm going to put it up there just so that we have it for like reference. You don't have to if you don't want to. And then we'll connect those dots. And there's our graph, our little parabola. Alright, so we need roots. Where do we cross the x-axis here? 0, 0. Your axis of symmetry, where do you think that is? Probably 0, 0 again. So is it just 0, or what do we write there? X equals 0. You've got to have that x equals every time for your axis of symmetry. What about your vertex? Where's that at? 0, 0 again. That turning point is still 0, 0. And did it have a maximum or a minimum? A minimum. So what was your A value this time? 3. Okay, and that was positive, which is why our graph opened up. Yeah, that okay? So what happened to it now that that A value was a 3? It got skinnier, it got smaller, right? So what do you notice about the A value? So it's going to make it skinnier or wider, right? Can we just put that there? Is that an okay way to summarize that? Okay. So it's kind of backwards of what you might think it should be, but if that A value is small, did your graph get smaller or wider? Wider, right? When it was a fraction, we got wider, so the graph is wider. When that A value was big, what happened to your graph? It got skinnier. Alright, so this bottom section down here, we're just going to summarize all that we talked about with your A values. So if that A value is bigger than 0, it's positive. What does that mean about your graph? Which way does it open? Opens up. Opens up. So that's going to be that normal U shape. And is it going to have a minimum or a maximum? A minimum. So what if that A value is not positive, but it's negative instead? Which way would it open? Down. It's just going to flip it. So we're going to have like an N shape instead of a U shape, or like a frowny face. So is that going to have a minimum or a maximum? A maximum. Okay. Then we need to draw in some absolute value bars here. If that A value is bigger than 1, it was a big number, what happened to your graph? Yeah. It got skinnier. So we'll write skinny. When you go on into other maths, they're going to start using a little bit more sophisticated vocabulary there. And so that's going to be a vertical stretch. That's what that's going to be. Or no, I lied. A vertical, well, it'll be a horizontal compression is what it is. As long as you know skinny, I'm good. So what if that A value was less than 1? If it was like a fraction, what happened to our graph? It got wider. So as long as you know that it's getting wider, I'm good. Later on in math, they're going to start saying that it's a horizontal stretch. But again, as long as you know skinny and wide, you're good. That's all we need here. And the very last thing that we need to know there is your axis of symmetry. What's the little bitty formula that helps you find that? Negative b over 2a. Yep, we gotta memorize that. You gotta know it. The more you write it, the more you're gonna know it. The better you'll know it. And what does that give you? What else is it? It's the axis of symmetry or the x value of your what? Of your vertex. Good. Okay? So like this chunk of information, that's like stuff that we really need from today. Is that okay? Do we have questions on anything so far?